Hello class, welcome to the next lesson in module 13. This is we have two lessons that are added to the end of module 3. This is lesson 13, more on the Pythagorean theorem. And if you remember, at the end of module 2, we also did a couple lessons about the Pythagorean theorem. So this really today is more of a review than anything new. So if you followed me for the module 2 lessons of the Pythagorean theorem, these lessons should be a review, should be a little bit simpler. But this lesson starts on page 149, goes to page 156. So hopefully you have your workbook pages in front of you. Hopefully you have already started copying these notes onto a piece of paper or into a math notebook. So let's begin with the road so far. We learned at the end of module 2 that the Pythagorean theorem shows the relationship between the three side lengths. That's important. It's the side lengths of right triangles. So the Pythagorean theorem is the connection between the lengths of the sides, and it works only for right triangles. Very important to remember those two things. It's all about side lengths, and it's all about right triangles. So it does not work for isosceles. It does not work for scalene. It does not work for obtuse. It does not work for acute. It works for right triangles, always for right triangles. And it is connected to the side lengths. So we did talk about this in module 2. Let's review a little bit of it right now. You might recognize this diagram. This diagram should be similar to the one I drew in the last Pythagorean theorem lessons. There's a few things we can do first. First, we see, is it a right triangle? And yes, this is a right triangle because it has a 90-degree angle. I labeled it, I checked it, it's right there. So this is a right triangle. And we need to name the sides. Now, if you remember what we said when we did this last, and you should, we have a right triangle has two legs. The legs are the sides that meet at the right angle. The legs meet at the right angle. So one leg is A, the other leg is B, and they touch at the 90-degree angle. Side 3 is the diagonal across, opposite from the 90-degree angle. We call it the hypotenuse right here. This diagonal is also called the hypotenuse, and it is letter C. Very important to remember how to find the hypotenuse. It is opposite the 90-degree angle, and it is very important to remember that the hypotenuse is always C. The hypotenuse is always, always, always C. We have the two legs that hit the right angle, and we have the hypotenuse C opposite the right angle. And we use this information, and we come up with the Pythagorean theorem. This is the Pythagorean theorem right here. A squared plus B squared equals C squared. That shows you the connection between all three sides. That shows you the relationship between all three sides. So what the Pythagorean helps us do is when we know two sides, we can find the third side. When we know two sides, we can find the third side. We just use a little bit of algebra to find the third side. So if we know the two legs, we can find the hypotenuse. If we know the hypotenuse in one of the legs, we can find the other leg. So if we know two of them, we can find the third one. As an example, here's an example I did. Knowing two sides, we can find the third. For example, let's say leg A is 3, leg B is 4, and the hypotenuse C is not known. So in our diagram, be like, this is 3, this is 4, and this is still C, unknown. What we do is we take the Pythagorean theorem, we substitute the numbers, so we put 3 instead of A, 4 instead of B, and because C is unknown, we leave it alone. 3 squared, like we learned in module 1, is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. C squared does not change yet. After we get the 9 and 16, we add them together to make 25. So we know 25 equals C squared. Now there's two ways to finish writing this. You can say 25 equals C squared. You can stop right here if you want. This can work, except you can simplify this. If you stop here, that might be okay. But what I would really like you to do is, if it is a perfect square, if you can simplify it, please simplify it. So we know 25 equals C squared, so 25 equals C times C, which means C by itself has to be 5. Because 5 times 5 makes, if 5 times 5 makes 25, 1C is just 5. This is the symbol you can write. When you make the squared go away, you do the square root. So this really means the square root of 25 equals C, and the square root of 25 is 5. Now, square roots is not something we've really learned this year yet, but if you understand this, you can write it down and use it. If you do not understand this part, that's okay. You can just stop right here. But you can see from this example, we can use the Pythagorean theorem. We can use what we know to find what we don't know. We use what we know and the Pythagorean theorem to find the missing piece. That's what the Pythagorean theorem is all about. And in this lesson, we're going to do some work together about how to find the missing pieces. Just in case you've forgotten, since about a month ago when we did Module 2, we're going to do a little bit more practice today. So take a minute right now before we start our practice to pause the video, go back, make sure your notes are finished. Make sure if you have any questions, email me. And then when your notes are done and you are ready, you can unpause the video and we can start working on the exercises for Lesson 13. Okay, hopefully you took a few minutes to pause the video, go back, check your notes, ask any questions you need to ask, and you're ready to work ahead on the practice exercises. So let's take our note page away and make sure it's close by so you can still see it. And let's look at page 149. That is where the practice exercises for Lesson 13 start. So the directions underneath the exercises say, use the Pythagorean theorem to determine the unknown length of the right triangle. So we are going to find the unknown. We're going to find the missing side length. So let's look at number one. Number one, let's do a couple things first. Step one, make sure it's a right triangle, because remember, Pythagorean theorem only works for right triangles. So here we go. There is a right angle, so this is a right triangle. Check. Step two, find the legs and the hypotenuse. So here's a leg that is connected to the right angle, so I'm going to say that's leg A. Here's a leg, here's the other leg connected to the right angle, so I'm going to say this is leg B. And the hypotenuse is opposite the right angle, so this is C. Now you can see what we have here. We know the legs and the hypotenuse is missing. So let's use the Pythagorean theorem to find the missing hypotenuse. Pythagorean theorem is easy if you memorize it. A squared plus B squared equals C squared. Now let's substitute. A, remember, was 5, so we have 5 squared. B over here is 12, so we have 12 squared. Equals C squared. C we don't know yet. Now 5 squared is 5 times 5, so that's 25. 12 squared is 12 times 12, so that's 144. Equals C squared. C squared is still C squared. Now we are adding. 25 plus 144 is 169. So C squared is 169. Now you might not know that. I know that, but you might not know your math facts that high. 169 is actually 13 times 13. So 169, I know, and I'm telling you, is 13 times 13. And c squared is c times c. So 169 is 13 times 13. C squared is c times c. So what does c equal? Well, 13 times 13 equals c times c. So c must be 13. So for part A, c equals 13 after we use the Pythagorean theorem. Right there. If you do not know that 169 is 13 times 13, it might be worth trying to memorize that. Might be worth it. That way you do not have to use the square root button on your calculator. Might be worth knowing that. Or even if you just guess, you're allowed to just say, well, you know what? I know 12 times 12 is 144, 169. Let me just check. And then you could do 13 times 13. And then you can check and find out that it is 169. So even if you don't have a calculator, even if you don't have it memorized, you can just try it and check to see what you get. Okay, now let's see part B. Part B, if you look, the numbers are almost exactly the same. Instead of 5, we get 0.5 for A. And instead of 12, we get 1.2 for B. And C is still unknown. So if you look at this one, these two are together in number 1 because the digits are the same. The place value is just different. So 5 and 0.5, they both have a 5. It's just in a different place value. 12 and 12, they both have 12. It's just a different place value. This is 5 ones. This is 5 tenths. This is 12 ones. This is 12 tenths. So the digits are the same. The place value just changed. So my prediction right now, I'm going to predict that C was 13 up here. My prediction right now is that I'm going to still get 13 just in a different place value. So I'm going to predict that C for part B, that this answer is probably going to be 1.3. I don't want to just write down 1.3, but that's my prediction. And I'm going to check it by doing the Pythagorean theorem again. So I saw that the place value changed only. So I'm going to guess that the only difference for part A and part B is going to be the difference in the place value. But let's check it. Let's check it. So for part B, I'm going to use a different color, and I'm going to draw an arrow over here so that I kind of ran out of room right next to it, but I have plenty of room over here. So A squared plus B squared equals C squared. This time A is 0.5. This time B is 1.2, but C is still unknown. So now I have 0.5 squared, which is 0.5 times 0.5. Now, if you don't know how to do that, it is probably something where you should type it into a calculator, 0.5 times 0.5. But it is actually 0.25. That's what it's going to be. Now, 1.2 squared is 1.2 times 1.2, which is actually going to be 1.44. Now, I know you might not believe me and you might not have a calculator next to you. Let me get my calculator out just so I can prove to you that I am right with this. Here's my calculator. We do 0.5 times 0.5, 0.25. We do 1.2 times 1.2, and we get 1.44. If you actually have a scientific calculator, or if I turn my calculator sideways, I get a scientific calculator. There actually is a square button. So you can type in 0.5, and then there's this button right here that has a little x squared. If I just do that, that's the same as squaring it. So I get 0.25. That's how you use a calculator if you want to use a calculator for this. Anyway, I did not need one because I know my math facts pretty well. And we get these decimal answers. Let's add them together. 0.25 plus 1.44 gives us 1.69 equals c squared. And then we have to do, well, if you look at this, if you look at our work from part A and part B, so far it's looking pretty identical. So far it's looking pretty identical. The only difference is the place value for our numbers. So you can probably guess that our prediction so far is going to be pretty close. So in fact, if you do this, 1.69 equals c squared, this is actually 1.3 times 1.3 equals c times c. 1.69 is 1.3 times 1.3. So c is 1.3. Our prediction was right. For part B, c equals 1.3. The only thing that changed, we have 13 in the ones place. Now we have 13 stopping in the tens place. Same digits, just different place values. But we got a little bit more practice with the Pythagorean theorem. Let's go to number 2, exercise 2, and get some more practice with the Pythagorean theorem. Determine the length of side B in each of the triangles below. Okay, for this time, B is missing. So first, check to make sure it's a right triangle. And yes, this is a right triangle because there's the right angle. Second step, find your legs. So I'm going to say this is leg A, and that leg is 4. This is leg B, and it's unknown. And I know these are the legs because they are touching the right angle. The hypotenuse is opposite the right angle. So start at the right angle, go the opposite. And this is the hypotenuse C. So now we know A, we know B, we know C, and we know it is a right angle. Now we can use the Pythagorean theorem to help solve this. So let's do a squared plus b squared equals c squared. And we're going to substitute it. A, the first leg, is 4, so 4 squared. B is unknown, so we just keep it the variable b. This time c is 5 squared. So 4 squared plus b squared equals 5 squared. Now let's do our math before we do our algebra. Let's just solve this. 4 squared is 4 times 4, which is 16. B squared stays the same. We still don't know it. 5 squared is 5 times 5, which is 25. Now we want to get the b all by itself. So what I'm going to do is I'm going to do minus 16 to this side. Because 16 minus 16 is 0, and 0 plus b squared is just b squared. But when I do minus 16 over here, I have to do minus 16 over here. So 25 minus 16 is 9. So now I have b squared equals 9. And if you're good with your math facts, you already know what b is. You know b squared is b times b. And you know 9 is a perfect square, which is 3 times 3. So if b times b equals 3 times 3, that means b by itself just equals 3. So the missing leg is 3. The missing leg is 3, using the Pythagorean theorem. Now we do have part B right here, and let's check it again. First, yes, it is a right angle. A is a leg next to the right angle. So here's the right angle. Here's leg A. Leg A is 0.4. Wait, look at that. Up here, A was 4. A down here is 0.4. So it looks like the only thing that changed was the place value. B has to be the other leg, so the other side connected at the right angle. So this is B, and that's unknown. The hypotenuse C is opposite the right angle, so here's the right angle. Go opposite, and here's C right here, which is 0.5. So again, you see A was 4, now it's 0.4. C was 5, now it's 0.5. Same digits, different place values. 4 ones and 5 ones. Now we have 4 tenths and 5 tenths. So if I'm making a prediction right here, I'm going to predict that for this one up here, part A, B was 3. I'm going to say it's going to be the same digit, just a different place value. My prediction is that B will be not 3 ones. This time it will be 3 tenths. But let's use the Pythagorean theorem to check and see if my prediction is correct. So my prediction right here, I'll write it down. My prediction that B will be 3 tenths. That its place value will change the same way the other place values changed. So let's do the work, just to double check myself. A squared plus B squared equals C squared. This time A is 0.4, B is still unknown, and C is 0.5. Now we do some math, and I know this is decimals, so if you'd like to use your calculator to help you, you can. 0.4 squared is going to be 0.16. B squared is still B squared because we haven't found B yet. 0.5 squared is 0.5 times 0.5, which is going to be 0.25. There we go. Now we have to do the same thing we did before. We want to get the B by itself, so we are going to subtract 0.16 from both sides, because 0.16 minus 0.16 makes 0. And 0 plus B squared is just B squared. But when I do minus 1600ths over here, I have to do minus 1600ths on that side. Here, let me do that one. Minus 1600ths. So 2500ths minus 1600ths is going to be 900ths. If you do the subtraction, 900ths. Now we know B times B has to equal whatever this is. So this is actually going to be 0.3 times 0.3. If you do not believe me, get out your scientific calculator or get out your phone and open the scientific calculator function. Just like right here. You can type in 0.3 and then click the square button, and you get 0.09. Or you can work backwards, and you can find the square root button, which looks like that. Square root of 0.09, 0.3. So we know that B is going to be 0.3. My prediction was correct. That's our answer. So it's a very good way. So this is so far showing us how if you have decimal sides, don't let the decimal sides confuse you. Don't let them trick you. Just turn the decimals into whole numbers. Just change the place value, solve it the easy way, and then change the place value back. But really the big goal of today is to practice your Pythagorean theorem. Can you do the Pythagorean theorem? In fact, it doesn't even bother me very much if the decimals are confusing you. If you can do the part without the decimals, I'll be happy today. The decimal part, you might need to use your calculator to help you a little bit today. If you want to use your calculator today, that is perfectly fine. If you have questions about how to use your calculator and where these buttons are, email me, message me. We'll set up a private meeting, and I can show you how to use your calculator. There's even an online calculator on our Symbaloo page that you can use to do this for you. So I will show you how to use the online calculator. I will show you how to use the calculator on your phone. I will show you how to use just a regular calculator if you are having trouble with that today. You just have to ask. But right now, let's go to our last exercise to get more practice with the Pythagorean theorem. And it is on the next page, page 150. Now you'll notice this looks a little bit different than what we've done so far. This is two triangles back to back. And it's asking us to determine the length of QS. And the hint, use the Pythagorean theorem twice. So if you look, QS is this long section right here. So what you need to look at this is you need to say, okay, well, if QS is the long one, QS equals QT plus ST. QT and ST together make QS. So if I want to find QS, I have to find this one and put them together. I have to find this and put together. In fact, I'm going to say I need to find B, and I need to find, let's call this one B prime. I need to find B and B prime if I want to find QS. So now I can use my information to find B and B prime. So I'm going to have to use the Pythagorean theorem twice. So first, these are both right triangles. These are both right triangles. And let me show you both right triangles I'm talking about right here. We are going to use the Pythagorean theorem for both triangles. Oh, got a little bit crooked with my highlighting there. So you can see that we need to find the blue and the pink triangles and put the bases together. So we have the blue triangle, which is triangle QRT, and we have the pink triangle, which is triangle RST. So we have two triangles, so we need two Pythagorean theorems. Now, if you look for triangle QRT, we're missing, let's do A, B, and C for QRT, and let's do A, B, and C for RST. Now, B is unknown. For B is what we're looking for down here. I already labeled those for you. So for the blue triangle, B is unknown. And for our pink triangle, B is also unknown. Now the other leg, so one leg is unknown, but the other leg, leg A, oh, messed up my color coding. The other leg, leg A, we do know. Look at this, right here is 15. Now 15 is going to be A for both triangles. Both triangles share this line right here, this segment. The blue triangle, this is 15, and the pink triangle, this is 15. And 15 is connected to the right angles, so that means it is a leg. So leg A is 15 for the blue triangle, and leg A is 15 for the pink triangle. Now we need the hypotenuse, C. Well, if you look at the blue triangle, here's the right angle. Opposite the right angle is the hypotenuse, so that's 17. And for the pink triangle, here's the right angle. Opposite the right angle, the hypotenuse is 25. Now we have A, B, and C for the blue, A, B, and C for the pink. We can use the Pythagorean theorem to find the missing piece in both of them. We're going to use the Pythagorean theorem to find the missing piece in both of them. So let's work on this. Let's do the blue one first, since I put that on the left. A squared plus B squared equals C squared. So substitute what we know. We know A is 15, B is missing, and C is 17. Now we need to do a little bit of math. But so you can use your calculator if you need to. But 15 squared is 15 times 15, which is 225. B squared is still B squared. And 17 squared is 17 times 17, which is 289. And again, we want the B by itself, so we need to get rid of this one on the same side as it. So we do minus 225. Because 225 minus 225 makes 0, and 0 plus B squared is just B squared. But I also have to do minus 225 on this side. And if we do minus 289 minus 225, we get 64. Now, this is where knowing your math facts is super helpful, because you should know 64 is 8 times 8. So we get B times B equals 8 times 8. So B equals 8. So I'm going to add this to my diagram up top. In the blue triangle, B equaled 8. Now we need to do the Pythagorean theorem with the pink triangle. And it's going to be, the Pythagorean theorem is still the same. A squared plus B squared equals C squared. We just have a couple different pieces. A squared is still 15, 15 squared. B squared is still the one we're missing. C is 25. 15 squared, do not type it into your calculator again, because you already did it over here. 15 squared was 225 for the blue. 15 squared for the pink is still going to be 225. You might need to do 25 squared again, but if you do 25 squared, you find that that 25 squared is 625. Now, again, you want to get the, oh, this should be a plus. I'm sorry. 225 plus B squared equals 625. So I need to do minus 225 from both sides to make 0, because 0 plus B squared is still B squared. And I do 625 minus 225. 625 minus 225 is 400. Now, you could probably guess what B is going to be for this one, but you can use your calculator to check. But I'll tell you, 400 is actually 20 times 20. So if 20 times 20 makes 400, B times B makes B squared. That means B by itself is 20. So the blue triangle, B was, the leg B was 8. In the pink triangle, leg B was 20. So let me label it up there. So now we know B, the leg B for blue, leg B for pink, but that's not what the question was. The question was asking us QS. But we know QT was the blue triangle. QT was the piece of the blue triangle. And ST was the leg B of the pink triangle. So to find QS, we take QT, which was 8, and we take ST, which was 20. We put them together just like they were put together on the diagram, and we find out that QS is 28. And that's how you find the length of both of them together. You have to use the Pythagorean theorem for this triangle that we labeled blue, use the Pythagorean theorem for this triangle we made pink, and then you find the missing legs, you put them together, and that tells you how long the whole triangle is. And this is a skill people use to find different lengths of things that are difficult to measure on their own. They use the pieces. Those are actually our 3 exercises. That's all the exercises and examples we had today. What I'd like you to do now, take a little bit of a break, go back and look at the exercise again. If you need to rewatch the video, make sure you write down all my work, make sure you catch up, making sure you understand everything. If you do not understand it, please send me an email asking more questions, and we can even set up a Google Meet where I can help you. But so go back, make sure you understand everything. When you are ready, you can unpause the video, and I will tell you about the problem set and the exit ticket for today. Thank you for coming back. Thank you for looking at your question. Thank you for looking at the exercises. Thank you for asking any questions you needed to ask. Hopefully you understood all the exercises and you're ready to use the Pythagorean theorem independently on your own. So let's check. Let's leave page 150, and you'll see on page 151 is your exit ticket. We'll talk about that last, so I'm just going to slide it to the back because the exit ticket is the last thing you'll do. On page 153, you'll see the homework helper, where they give you another problem. They give you another problem. They give you the solution, and they told you what was going on in their thinking, and they did it twice. So they have 2 more examples with the work and with their thinking to help you with your problem set and your exit ticket. So if you need more help, use the homework helper. But on page 155 is the problem set. So let's look and talk about the problem set. So problem set number 1, it's the length of C in both of them. So you are finding the hypotenuse. Use the Pythagorean theorem to find the hypotenuse. And number 1 is like exercise 1 on page 149. So if you need to know how to do exercise 1, go to page 149, look at exercise 1. But this time, C is missing. This time, C is missing. For problem set number 2, you're finding side A. So you're finding the missing leg A. So here's a leg A and here's a leg A. And you're finding the missing leg. Again, you're going to use the Pythagorean theorem. And if you need to see how to do this, you want to look at exercise 2 on page 149. That will help you do number 2 on page 155. But you're still using the Pythagorean theorem, except for this time a leg is missing. The problem set continues on to page 156. Page 156 tells you that this time the leg B is missing. So this time in both of them, you have missing leg B. So it's going to be just like number 2. This time leg B is missing. And if you need help with this one, exercise 2 on page 149 will help you with this one. Exercise 2, page 149, will show you how to use the Pythagorean theorem to find a missing leg. Number 4 on page 156. Again, the side A is missing. So again, we have leg A is missing for both of these. Leg A is missing. So because a leg is missing, you're going to use the Pythagorean theorem and a little bit of algebra. But for help, again, go to exercise 2 on page 149. Exercise 2 on page 149, I show you how to find a missing leg. So those will help you. You can know how to do that. You know how to use the Pythagorean theorem to find missing pieces. Oh, number 5 on your problem set, I forgot. What did you notice in each of the pairs of problems number 1 through 4? What might you have noticed to be more how might what you notice be more helpful in solving problems like these? This is where they talk about the place value stuff. Remember, we talked about how the numbers did not change, the place value changed. You should see that same pattern happening in all of these. So tell me how that can help you if you know that changing the place value of the pieces changes the place value of everything. After you finish all 5 of those, also remember that for the problem set, my answers are posted online in the Google Classroom. So you can check your answers with mine. When you know your answers are right and you know what you're doing, you can work on the exit ticket on page 151. And this exit ticket problem should look familiar because it is just like exercise 3 on page 150. You are finding BD. You're finding this side right here of the larger triangle. So just like exercise 3 on page 150, use your skills with the Pythagorean theorem to find this whole length right here. My answers for the exit ticket are not online, but if you've been following along, if you've been doing your best, if you were listening during the presentation in the video, you should know how to do all of these. But if you need any help, remember that I am here to help you. Message me and I will jump on a Google Meet to help you out. When you are done with your exit ticket, remember to take a picture of page 151 and to turn it in on the Google Classroom. But that is the lesson for today. I will see you again for lesson 14, which is more work on the Pythagorean theorem. Get this work done and have a great day.